Okay, number 23. So we have a of t equals this, b of t equals that. T represents the amount of time in days. On which day will the amount of materials be equal? So all we have to do is graph this, graph a of t and b of t, and see when they are equal. So y1 equals a of t, which is 1,000 times 0.5 to the power of 2t, using x instead of t, just a variable. Doesn't matter which letter we use. Oops, I left that a 0 here. So I'm gonna, instead of erasing it, I'm gonna insert much faster. Times. Be careful about typing it in exactly as it's written. If you're not going to get the right answer, always check your y equals, make sure you typed it in correctly, because that's a very common mistake. Okay, so now we're going to graph. And I'm probably going to have to zoom 0. Zoom fit, maybe not. So now it's easier to see with the color, but as you can see, they overlapped each other. Right? One went over the other. It's even clearer if you look at the table. Right? You can see that y1 and y2 are the same throughout. So it looks like there's no specific day that they're equal. They're always equal, which is choice 4. Okay, 24. So all you have to do here is cross out the like terms. 1 hour, 1 hour. Foot to feet, mile to miles, and we are left with inches to minutes. So inches per minute. Inches per minute. Okay, solve algebraically. So subtract 2,000 from each side, and subtract 1.02x from each side. Right, we want to get y. We want to get x alone. So 36,000 minus 2,000 is 1,600, and we're going to be left with 0.02x. Divide each side by 0.02. If we were dividing by a negative or multiplying by a negative number, we would have to flip this sign, but we're not, so we don't have to do that. And we get 80,000. Okay, you could also solve non-algebraically by graphing. Y1 is this, Y2 is that. Find the point of intersection. And then you'll get 80,000, and you'll have to figure out that that x has to be greater than 80,000, but you won't get full credit for that. Okay. So state the type of function that best fits the given data. So if it's increasing by a consistent amount, meaning it's increasing by the same amount every game, then it's going to be linear. If it's doubling or tripling every time, then it's going to be exponential. So let's see, from 13 to 14, it was 435 minus 348. And let's see, from, let's say, game 17 to 18, if it's the same amount, then we know that it's linear. 87. So it's going up by a constant amount, 87 each game. So it's a linear function, and the justification is because it's going up the same amount each time. Okay. Solve algebraically. So there's another number of methods you can use. You could use the quadratic formula, which is negative b. They give this to you in the reference table, so you don't have to memorize it. Negative b plus or minus the square root of b squared minus 4ac over 2a. So in our case, a is 1, b is negative 8. Careful about that negative. Right, negative there. And c is negative 9. So negative b, right, which is going to be a negative 8, which is going to be positive. We'll do that in the next step. Plus or minus the square root of b squared, so that's negative 8 squared. These parentheses are important. Minus 4 times a is 1 times c is negative 9 over 2a. A is 1, so okay, now let's start simplifying it a little bit. Negative 8 is positive 8 plus or minus the square root of negative 8 squared is 64. When you type into your calculator, you need these negatives, otherwise it's going to give you negative 64. But the negative 8 squared is positive 64. So 64 minus 4 times 1 is 4 times negative 9 is negative 36 over 2 times 1 is 2. Okay, now let's simplify the inside of the radical. 64 minus negative 36. So that's this, subtracting a negative is the same as adding. If you're not sure, plug it into your calculator. So we get 100 there over 2. 100 is the same as, the square root of 100 is 10. So it's 8 plus or minus 10 over 2. Let's just bring it over here. Split it up. 8 plus 10 over 2. And 8 minus 10 over 2. 8 plus 10 over 2 is 18 over 2, which is 9. 8 minus 10 is negative 2 over 2, which is negative 1. So those are our two solutions using the quadratic formula. Now you can also use completing the square or factoring. Let's do factoring. So we can't always do factoring, but in this case we can. We just need a pair of numbers that multiply to negative 9 and add up to negative 8. So you could pause it for a minute to think about it. So the two magic numbers that multiply to negative 9 and add up to negative 8 are, let's see, well, let's start with that, minus 9 plus 1. Right, that multiplies to negative 9 and adds up to negative 8. So, right, so this factors to that equals 0. So either x plus 1 equals 0 or x minus 9 equals 0. If x plus 1 equals 0, then x equals negative 1. X minus 9 equals 0, x equals 9. And so we get the same solution using either method. You can also do it by graphing y1 equals left side, y2 equals right side, which in this case is 0, and finding the 2 points of intersection. But I don't think you will get full credit, or in this case, any credit for that. Some problems you'll get half credit. Okay, explain the first step to solve the given equation. So if you're doing using the quadratic formula, you would say I plugged it into the quadratic formula. If you're factoring, the first step would be factoring. Okay. Okay, over what time interval is the b's rate of change 0 feet per second? So let's say from 0 to 2, right? It's increasing in height. Its rate of change is not 0. Its rate of change is actually 1. It's going up 1 over 2. From 2 to 6, its rate of change is 0, right? It's staying at the same height. It's staying at 1 feet. From 6 to 10, it's going up. Right, and it's going up at a rate of 1, 2, 3 over 1, 2, 3, 4. So it's going up at a rate of 3 over 4 from here to here. So that's not 0. From here to here, it's going down at a rate of 1, 2, 3 over 1, 2. It's going down at a rate of 3 over 2. Over here, it's going up at a rate of 1 over 1, 2. It's going up at a rate of 1 over 2. From here to here, it is staying the same. So the answer is from 2 to 6 and 14 to 15, and the reason is because it stays at the same height. It doesn't change height, it doesn't go up or down. Okay, graphing. Okay, graphing, this shouldn't be too hard. All you have to do is plug into the y equals and then use the table. It's hard to graph it straight from the graph because you don't know where to how it matches up. So the best thing to use is the table. So let's see, 2 to the power of x minus 7. Okay, and it's a good idea to write out your table. To write out your table on the page, just to show your work. Okay, so let's say when x is 0, you can see y is negative 6. So let's go to x is 0 is this line. 1, 2, 3, 4, 5, 6. So this is the y-intercept at 0, 6. Okay, next point. Let's see, 1, negative 5. So when x is 1, which is along this line right here, x is negative 5, so that's 1 up. Oh, this should have been negative 6. Okay, negative 5, that's right here. Next point, 2, negative 3. So this is negative 5, this would be negative 4, negative 3. 3, 1. So 1, 2, 3, and 1. That would be the point 3, 1. 4, 9. So that's going to be 1 over. It's going to be 9 up. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that should be enough. And then, once you have your dots there, you can take a look at the graph, just to get an idea of what the curvature should look like. And it'll look something like that. Make sure to put arrows at the end to show that it goes on. And also label it as f of x. Okay, there, that's the first part. Next part, if g of x, that's a different function, is 1.5x minus 3, determine if f of x is greater than g of x when x equals 4. So this, again, is similar to question number 2 we had at the beginning. They want to know when x is 4, meaning plugging in 4 for x. So let's start off with the first function f of x, which we just drew. So when x is 4, what is f of x going to be? In other words, what is f of 4? So we said when f was 4, 1, 2, 3, 4, that was this point right here, right? 4, 9. Right, let's just double check with our table. 4, 9. So f of 4, meaning when x is 4, the output y is 9. Now what's g of 4 going to be? So we're just going to plug it into this, right? G of x equals 1.5x minus 3. 1.5x minus 3. So we can graph this and then go to the table just like we did with f of x, or we could just plug it in ourselves. 1.5 times 4 minus 3. 1.5 times 4, if you're not sure, type into the calculator. And even if you are sure, can't hurt to double check. 4 times 1.5 is 6, minus 3 is 3. So G of 4 is 3. F of 4 was 9. So yes, f of x is greater than g of x when x is 4, because f of 4 is 9 and g of 4 is 3. Determine algebraically the zeros of f of x. Okay, so we could find the zeros by graphing, right? You graph y1 equals this, y2 equals 0, and find the points of intersection. Since there's a 3 here, the exponent is 3, there will likely be 3 points of intersections. However, that will only give you 1 point, only partial credit, half credit, because it's not an algebraic solution, it's a graphing solution. The algebraic solution looks like the easiest way to do this would be by factoring. So we can factor out the greatest common factor, would be a 3x, times, factoring out a 3x, we get x squared here, plus 7x, plus 36x divided by 3x is 12, equals 0. Okay, so that's greatest common factor factoring, first step. Next up, we're going to want to factor this thingy out. And this is where actually doing the other method, graphing and finding the zeros, if you find that first using graphing, it can make it a little bit easier to figure out what numbers you're going to need here to factor this, right? We're going to need a pair of numbers that multiply to 12 and add up to 7. So if you're having trouble figuring that out, you can use the graphing to find the answer and then work backwards to show your work. So the pair of numbers that multiply to 12 and add up to 7 are, let's see, 6 and 2. No, that doesn't work. 12 and 1 doesn't work. Am I missing something here? Multiplies to 12. Oh, 3 and 4. Of course. Right? And if you graphed it and found the points of intersection, you would have seen that, as we'll see in a minute. Okay, so if 3x times x plus 3 times x plus 4 equals 0, either 3x equals 0, x plus 3 equals 0, and x plus 4 equals 0. Okay, 3x equals 0, that means x will equal 0, because 0 divided by 3 is 0. So x equals 0, or negative 3, x equals negative 3, or minus 4, x equals negative 4. And those are the zeros. What I meant before by if you graph it to find the solution, then that can help you figure out what the factors are. When you graphed it, you would have found that the zeros are 0, negative 3, negative 4. If you know that those are the factors are negative, it has factors of negative 4 and negative 3, then you know that it's going to have, if it has zeros of negative 4 and negative 3, then you know that it's going to have factors of x plus 4 and x plus 3. And if it has 0, then it's going to have an x factor also. So that's that. Next. Okay, so I think the simplest way to look at this would be the range, right? What's the lowest number here? The lowest number here is 60, and the highest is 87. So Miami goes from 60 to 87. Over here, the lowest number looks like it's about 61, and the highest is 74, it looks like. But clearly nothing in the 80s. So this one has less variability, right? Less variance. So the answer would be Los Angeles has less variability. Explain how you arrived at your answer. Because it has a smaller range of temperatures. Okay. Okay, so over here they don't say that we need to solve algebraically, so we can actually do it by graphing and finding the points of intersection first. But this is not hard to do algebraically anyway, so I'm just going to do it really quickly first, and then we'll do the other way, graphing. Add 5 to each side, we get 4x squared equals 80. Divide each side by 4. We get x squared equals 20. Take the square root of each side, and we get x equals, don't forget positive or negative. Got it, include that there, otherwise you'll lose a point. Positive or negative, the square root is 20. Ooh, this is going to be tricky here. Actually, it will be tricky to do it by graphing, because notice that it says the square root of 20. So that's an irrational number. It's going to come out as a long decimal. So it's going to be a little bit tricky to get that. But let's see what we can do. 4x squared minus 5. That's y1, left side. y2 is right side. 75. Okay, we're going to have to use a zoom fit, probably. That will work best. And there are our 2 points of intersection. Okay, so let's get it. So let's first go for the one on the right. 1, 2, 3. So now notice that they're giving us this long decimal. 4.72. So that's not going to be an exact. That's not going to be an exact answer. They're rounding it, and the question told us that they want an exact answer. So let's see if there's something we can do about this. Okay, so let's copy down 4.472136. Is that correct? 4.72136. Okay. Now let's see if we can. That should tip us off to the fact that there's so many decimal points there. That should tip us off to the fact that it's probably the square root of something. So if we want to know how to write that in terms of square root, we can try squaring it. 4.472136 squared. Hopefully it'll come out to close to 20. There we go, 20.4. So that tells us that 4.472136 is the square root of 20. So that's a little bit of a solution that you can do there, right? If you graph the other side, right, you have to do calc intersect again. To get the other side, you'll get negative negative what we just got. So that will come out to negative square root of 20, and you'll know that the answer is plus or minus the square root of 20. But really the algebra here is not that hard. You should be able to do it. Okay, part 3. Okay, increase by 2.5% per year. So if you remember, like we said, by the pumpkin, an increase of a certain percent per year, right, means that you multiply by 1 plus the percentage, which in this case is 2.5. So you would multiply by 1.025, right? 2.5% is 0.025. So plus 1 is 1.025. You would multiply by 1.025 each year to get the the new increased value. So an increase of 2.5% per year would be 450, right? That's the starting amount, times 1 plus the rate, which is 0.025. So that's what we would do each year, right? After the first year, we would do 450 times 1.025. Then the next year, we would multiply by 1.025 again. And the next year, the same thing over and over. So how many times are we going to have to multiply by this 1 plus 0.025? Well, however many years it is. So this is to the power of t. So we can just simplify it a drop. 1.025 to the power of t. And that would be the solution. So the general formula for an increase of a certain rate or percentage per year is the amount is going to equal P, which is the starting amount, the principal, times 1 plus the rate to the power of t. That's the general formula for an increase in percentage. Okay, an increase of a set amount, right? If let's say something is increasing $5 every year, it's going to be P, the principal starting amount, plus the amount that it's increasing, right? Let's call that D for different, times X. Okay. Now, assuming that the doll's rate of appreciation remains the same, when will the doll's value be doubled? Will the doll's value be doubled in 20 years? Well, let's see. In 20 years, how much will it be worth? Well, using our formula, right? Using this formula here, to find out how much it will be worth in 20 years, we just plug in a t for 20. So it's going to be to the power of 20. Now let's just plug that into our calculator. $450 times 0.025 to the power of 20. That gives us 737. And is that doubled? Well, let's see. Doubled would be 450 times 2, which equals 900. So no, that would not be doubled in 20 years.